Hey guys, welcome back to my channel. So today we are gonna start with DSA playlist, and this is the first program. Find K closest element. It is a lead code program. So let's go. Find K closest elements. Given a sorted element array and two integers are given K and X, return the K closest integers to X in an array. The result should be in ascending order. So we have 1, 2, 3, 4, 5 given, and x is given. So we need to find all those four elements, okay, which are closest to 3. Okay. So if we have 1, 2, 3, 4, 5, and we have to calculate the distance of 3 from each of the numbers, and the closest 4. Why 4? Because k is given as 4, that has to be picked. Okay. So distance of 3 from 3 is 0, and with 2 it is 3 minus 2 1, with 4 it is also 1, and with 1 it is 2, and with 5 it is 2. So we have to pick 4, right? So this definitely come under the window. But what about these two? So there is another constraint mentioned here, that is, if the distance between two numbers with the given number is same, then the smallest one has to be picked. So this has to be picked. Okay. And how we are coming up with the answer is, if you see that 1, 2, 3, 4 is the equidistance to 1, 0, 1, right? And if suppose we are just picking up 0, 1, 1, and 2, okay? I just picked up this. Now, if we have to see, uh, 0 is mapped to what? 0 is mapped to 3. Let me use a thinner one. Yeah, 0 is mapped to 3. 1 is mapped to 2, then it is mapped to 4, and then 2 is mapped to 1, right? And then we just have to arrange it in ascending order. 1, 2, 3, 4. That is also the ask of the question, right? Here, we have to arrange it in ascending order. So that is how we are coming up with the answer. So there are several approaches. We can go with binary search, but also a little bit of sliding window comes into the picture because we have a window given. Okay, so let's see how that is done. So how we are planning to approach the question is, we'll be taking a left pointer and a right pointer. And you understand that in a binary search, whenever we have left and a right pointer mentioned, like a midpoint definitely comes into the picture. Okay, so there is one thing that needs to be understood with midpoint. So let's understand that concept first. Now, and we have our index mentioned. Our left pointer starts with 0, and our right pointer starts with, this is the array, so it starts with array dot length minus k. So k is our window, which is 4, and our x is 3. Okay, so as we check in binary search, we'll check for while left is less than right. While that is happening, we will create a midpoint, right, by 2. We'll create a midpoint, and accordingly, like we'll be changing the midpoint and doing computation or so. So we know that a midpoint is in the picture, and a particular value which is given, that is in the picture, right? ARR mid, that is our midpoint. And so what is this? This is basically the window, right? If we consider M mid is equals to 0, then what we are getting here is our exact window. So suppose we have a condition when X is here, okay? So just mind the distance between array of mid and X is just this much, and it is much less than the distance between X and array of mid plus K, right? So this needs to move in the left direction, right? Our right border or right boundary needs to move in the left direction. So for that, what we need to do is, this is a right boundary. We will assign it with mid. Whatever is mid, we are going to assign it with that. And again, it can happen that X can be here. And again, we see the distance. This is much less as compared to this. Okay. Again, this needs to move in the left direction. We are going to do the same thing here. All right. And in these two demonstrations, what you need to understand is, if X is here, means the value of X is smaller than array of mid. And here, the value of X is greater than array of mid, because we are dealing with a sorted array. Okay. Now, for third condition, we can consider that X is here. So this distance, X and array of mid plus K, is much less than this distance, right? So the left boundary has to move this side. So we need to do mid plus 1 to the left boundary. Okay. And for the fourth type, suppose X is here, much closer to array of mid plus K, right? This distance is much less than this distance. So again, the window needs to move in the right direction, right? So again, we are going to do this. So this is basically what we are doing, and we are going to do in our algorithm. Okay. Having seen this, let's look at the code now. So let's start with left boundary is equals to 0, right is equals to array dot length minus k, while left is less than right, int mid is equals to L plus R by 2. Now comes our if condition. If X minus array of mid is greater than array of mid plus k minus x. So basically we are talking about this condition. Here if you see, the distance between array of mid and x is greater than the distance between array of mid plus k and x, right? Either can be considered. Since we are doing x minus array of mid and that is positive, so it's this one, right? Because x is greater as we are dealing with a sorted array, right? So for this, we have to return the condition L is equals to mid plus 1. And for the other one, right is equals to mid. So coming back, we have to, if that happens, then L is equals to mid plus 1, else right is equals to mid. Okay, that is all in our while loop, and then we just need to form a loop for writing, uh, because we need to fill our answer in list of integer. So int I is equals to L, it will start with the left index, and I will be less than L plus K because we have to consider the window, and we just need the number of elements which are mentioned in the window, that is 4. That is why. And our return type is a list of integers, so let's quickly create one list of integer here. And we just need to return the list of integer. Let's run this. It's accepted. Yeah, it works. So thank you guys for watching this, hoping that you understood the question, and it's one of the most asked question. I guess it was asked in Facebook London interview, and keep practicing. And before I forget, the time complexity for this is O log n minus k, because here this is what we are considering. This is n minus k is that we are considering in the time complexity, and in the space complexity it is O of k because we are just filling the number of elements that is mentioned in the window. Okay, so yeah, thank you again for watching this. Let's catch up in the next video.